Hey, today we're going to talk about one of our subatomic particles. In particular, we have the electron. And the electron is a fast-moving particle. It has a negative charge, and it hangs out in an area called an orbital. And an orbital is a general area where there is a high probability of finding an electron. Now, there are very complicated views of an orbital, but for our purposes, our version, or the wave mechanical model of the atom, it's going to look something like this. This is the nucleus where we have protons and neutrons. And the charge of a nucleus is always positive, because protons are positive and neutrons are neutral, or it has a zero charge. And then we have different orbitals, and they are determined by their quantum level. In other words, the quantum level is 1, 2, 3, 4, 5, 6, 7. Simple enough. But we're going to look at magnesium in particular. And magnesium has a total of 12 electrons. And we know that because it has 12 protons. So when there's 12 protons, the number of electrons has to be equal. So I'll wait. Get out your reference table. And now we're going to look at what is called the electron configuration. So that tells us where these electrons are found in the atom. And what we have here is, I'm going to look up magnesium, and the electron configuration is 2, 8, 2. Now what that means is we're going to start from the inside, or the innermost orbital, and we're going to work our way out. So in the inner orbital, we have 2 electrons. And it's not 2 electrons hanging out, it's basically 2 electrons just floating all around really, really fast. So they're moving so fast that it kind of looks like a sphere. Kind of like the blades of a fan. When you turn the fan on, it goes really, really fast. It looks like it's solid, but it's actually made up of smaller particles. In the second orbital, we're going to have 8 electrons. And finally, in the third orbital, we're going to have 2 electrons. Now, this electron configuration is only the electron configuration for an element or an atom in the ground state. And all that the ground state means is it's the normal configuration. So if you look at the periodic table, whatever it says there, that is the ground state. Now we have something called the excited state. If I add energy to this magnesium atom, it's going to get these electrons really, really, really excited. And as I go out from the nucleus, I increase in energy. So the energy increases. So if I add a lot of energy to this first electron, it's going to bump to an outer shell. So instead of having 2 electrons on the outer shell, and it's going to have 1 electron on the inner shell and 3 electrons on the outer shell. So the new configuration, so magnesium in the ground state, is 2, 8, 2. Magnesium in excited is 1, 8, 3. 2, 8, 2, that equals 12. 1 plus 8 plus 3 also equals 12. Because it has 12 electrons, I can prove that it is magnesium. Now what does this really matter? How am I going to figure out if something is ground state or excited state? All you do is you look at the electron configuration and you match it with the electron configuration from the periodic table. If it is exactly the same as the periodic table, it's ground state. If you have a different number of electrons in one of the inner orbitals and you have more in the outer orbital, it's excited state. One last thing. Maximum number of electrons in the first orbital is 2. Maximum number in the second orbital is 8. Keep that in mind. If you have less than 2 in the first orbital or less than 8 in the second orbital, you can pretty much guarantee that it is going to be excited state. I want you to direct your attention right over here. Practice.